using Scholar GraphRAG powered deep research and analysis. Me and my teammate are IT professionals and new to the AI world. We have participated in this hackathon to learn about GraphRAG and how ArangoDB and CuGraph enables GraphRAG and multi-agents for deep research. So talking about the business problem, the idea here is that we want to see how GraphRAG can enable research areas. So the business problem states that we have inefficient research processes wherein it involves manually searching through vast amount of literature and analyzing that content, and often the connections are missed out. There is limited collaboration insights, and the information overload is high. Hence, there is a need of deep research where it is important to look at an interest area holistically and provide a comprehensive study. So we present our Scholar Graph app, which is a deep research agent for research. It's an agent who can generate plan for research strategies and execute the step using hybrid RAG, which is semantic RAG and graph RAG. It can refine the plan based on answers and prepare a comprehensive report. This is enabled through a research paper analysis agent who can answer simple, complex, and hybrid queries using AQL and NetworkX algorithm. Uh, this enables grounded research, which is powered by Graph RAG and NetworkX algorithms. We also use Graph RAG to enrich our data. So I'll speak about that. So talking about the dataset, we are using the archive HEPDH dataset as our base. We took this because this dataset is already having the details of various papers in the citation network. If not, we can also use GraphRAG to extract the data from the PDFs or the HTML using various scraping or PDF agents. So for a paper, we have the title, date of publication, the abstract, authors, and the journal. But we also augment this dataset with topics. So basically, we extract the various key topics which are being talked about in the research paper. So this enables our graph. So basically, we have a paper which is authored by an author. The paper has multiple topics, and the paper is cited by other papers. This is a single node paper graph for a single paper, whereas the entire graph with all the nodes is huge. So this is a representation of that. So how we did that? So number one, we selected our data. We data preparation and augmentation we did using structured LLMs. We persisted the data to ArangoDB directly using collections and the available Python libraries, and then we loaded the graph into a NetworkX object graph. We then proceeded to create a vector index. So we built a semantic vector index for the paper abstract and all the nodes. This enables providing good context to our tools, improving the accuracy. We can use the upcoming vector index of ArangoDB itself, or we can use an external vector index. And after that, we built the agentic app using LangGraph. And on top of it, we built the the deep research agent, which can use this research agent. So the available tools include semantic search, which uses the vector index. There is a text to EQL, which converts the text to a EQL, which can be used in code later. We have EQL to NetworkX algorithm tool, which converts EQL to NetworkX code and generates the output using CuGraph and NetworkX algorithms. We use text to EQL to text to directly get an answer. And then there is a text to NetworkX algorithm to text, again directly generating the answer. Overall, this is the architecture wherein we have the data sources. We have a data extraction agent which extracts the data, stores into vector database and the graph database. We have these tools available, and then we have a React-based agent which can use this tool to give a point-based answer. And then we have a deep research agent which plans the entire thing and uses this agent to generate the final outcome. So, like I mentioned, we have two agents here. These are some simple queries which are being answered. So it could be author collaboration, identifying papers written, listing all the topics of a journal, finding authors who have written papers on multiple topics, and so on and so forth. Complex and hybrid queries, so we can identify papers and then rate them using PageRank. We can detect communities of authors. We can find the shortest path between papers. We can again calculate the PageRank of top 10 authors based on their paper citation. So thereby, this one is a hybrid example where it first identifies the top 10 authors and then calculates the PageRank. And finally, we have a deep research report which analyzes the network of researchers who have published on string theory and then identify the potential bridge researchers. So it would generate a plan, execute, and finally come out with this report. We can see here that one of the researcher is identified as the bridge researcher between various communities. Thank you. So now I move on to the code. So this is our Jupyter notebook. So I'll quickly show what we do. So initially we set up the environment. We run our code on a RTX 4050 with CUDA 12 available. This is on a Windows machine, but we are using the WSL for the installation and then connecting to that on Ubuntu 24.04. We install all the libraries. We quickly check if the GPU acceleration is available, and we can see that there is a speed up of 2.4 for the PageRank algorithm. We import the required libraries. These are the environment variables which are set to connect to the ArangoDB. We then start with importing the data. So this is where we download the data from the Stanford website and then unzip it. Then we start reading it and generate the edges and the vertices. So here we start extracting the information from the abstract and generate the entire paper. Then we move on to extracting the topics from this abstract. So here we are using Olama, but alternatively we can use OpenAI as well, wherein we extract the top 3 topics. So once we generate the top 3 topics, we store that information, and finally for each paper we have this node wherein we have this data, wherein we have the abstract, ID, title, authors, general, and the various topics which are a part of the abstract. We then move on to extract all the vertices for papers, authors, and topics, and also define the edges. So finally, we get a total of almost zero point 0.5 million edges for the connections. We then move on to create the collection in ArangoDB using Python library, and then we import the data. So all the data is imported, and then we generate the graph. So when I generate the graph, this is what is created. So this is the graph that we have, wherein we have selected a couple of others to generate the graph. Moving on, so once we have that, we connect to the database and get the graph in a NetworkX object. Then we move on to generate the vector embeddings. So we generate the embeddings for the abstract, as well as we generate the embeddings for all the nodes. So this allows us to get the right context. So then now we connect to the graph and we preload, prefetch all the data, all the nodes. So we can see that we have 70K nodes and 483K edges. Next, we want to define the semantic search graph. So here we generate the vector store. And for example, if I ask for a question that what are the papers in string theory, it will go on and look at the abstract and identify the key papers based on that. It will also move on to list out the various nearby nodes as well here. So this is the graph schema. We get that. We also build a context manager wherein we store the output of various tools so that it can be passed from one to another. This enables our hybrid queries. This is a template for the hybrid query. We also build a context retriever. So for a given topic, given query, it will identify the key topics, papers, and the author nodes, which will help us to pass to our tools. When we talk of semantic search, so what are the tools available? One is the semantic search. One is text to AQL. So this will only return your AQL query, which is stored in the context manager and can be used by the other tools in a hybrid setup. We also have a text to AQL to text tool, text to NX algorithm to text tool. This has a robust retry mechanism. So if there is a error, it will retry with feedback. Finally, we have a NetworkX result in AQL. So this tool would be used whenever we want to use a NetworkX result generate the NetworkX output first and then call into AQL. Using all this, we generate the agent here, and we can then enable our different queries. So when I say what are the key papers in string theory, it is able to identify first the nodes and then give the final answer here. Similarly, for all the different queries, we can run it in a loop and then finally look at what is the output. So this is what we saw in the PPT. Complex queries, similarly, we run, we see the results. Hybrid queries, again, we run, we see the results. Some more hybrid queries. So in this hybrid query, we can see that it first went to retrieve the text to AQL and retrieve the various papers. It stored it in memory, and then it went to text to NX2 algorithm, wherein it used this AQL result in the code in order to generate the final answer. So this is how we can enable the hybrid queries. Finally, we have the deep research agent, which wherein first I give a report template, how I want the final report. Then I define the various steps of the agent. I generate a strategy creator, which will generate the strategy to respond to the query. There is a refiner agent, which will refine the strategy. And then there is a query graph agent, which will query our query graph to get the answers. Finally, we execute and get the answer. So here using line graph, we generate our workflow, and then we can call it. So for example, here, when I ask this question, it will call on multiple questions to get the answers and give the final report in a markdown format. Let's look at, say, for example, papers of this author. So we get the response. Similarly, let's look at a simple or a hybrid query. Sorry, complex or hybrid query. So for example, let me pick communities. So here it will identify first the papers using AQL, and then within only those papers, it will rate them based on the citation using PageLine. Okay, so there we see hybrid queries. Okay, so that's all from my side for the master agent. While it takes time, so it's available in the notebook, but basically it will use all of these to generate the plan and then the final response. Thank you for your time. Thank you.